In this video, we are going to look at how we can use the graph of our velocity function to gather information about either our position function or perhaps the acceleration. So in my diagram, notice that it is the velocity function that is graphed. So keep that in mind as we answer the questions below. And so the first question is, when does the body reverse direction? We know that the sign of the velocity function gives us the direction that our body is moving. So in our diagram, notice that to the left of 2, my velocity is positive. It's above the x-axis. So that means that my body was moving in the positive direction. But notice again, after 2, between 2 seconds and 4 seconds, my velocity is negative. So that means that my body was moving in the negative direction. So it changes from going from the positive direction to the negative direction at 2 seconds. And notice that I know my units are seconds because that was given to me. And then notice that it changes from moving in the negative direction to the positive direction at 4 seconds. So it changes direction twice after 2 seconds and 4 seconds. So part B, when is our body moving at a constant speed? And of course, that is going to happen when our velocity is constant. So in my diagram, it looks like that will happen between 5 seconds and 8 seconds. That's where my velocity is positive, or sorry, it is positive there, but the way that I know that the speed is constant is because my velocity is constant there. Next, we are going to actually graph the speed given that velocity graph. So notice this is just the same graph that I have up above. I've just recopied it so I can mark on it. And we know that velocity and speed are not the same, but they are related. In fact, speed is actually given by the absolute value of the velocity function. So if I have my velocity function graph, notice between 0 and 2 seconds, my velocity is positive. And if velocity is positive, then its absolute value is still itself. But notice between 2 seconds and 4 seconds, my velocity is negative. So there, I know that the speed will be the reflection of that over the x-axis when I'm graphing. But notice that's just the absolute value of the velocity function. Whenever velocity is positive, of course, its absolute value is itself. So if I graph the speed, it is just the absolute value of the velocity function. Next, we're going to graph the acceleration on the graph below. Notice that it's the same graph we had before. And of course, we are given the velocity graph, and we know that the acceleration is the derivative of the velocity function. So we are in effect just graphing the velocity of the function that's given, or the derivative of the function that's given. So I will notice that at these sharp points, I know that the derivative does not exist. So it's not defined at, for instance, t equals 1. And I'm graphing the rate of change of the given function. So between 0 and 1, I can see that it's just linear. So the rate of change is just going to be given by the slope of that line. And notice here that if I find the slope of that first little line segment, I know slope is rise over run. So here the rise is 2 and the run is 1. So I know the slope of that little segment is equal to 2. And I know that it's undefined at those endpoints, so it's just a constant in that interval. In the next interval, notice I have another little line segment, so again, the slope is just going to be the rise over the run, and it looks like my rise there is 4, the run is 2, but notice it's going in the negative direction. So the slope is negative 2. But I know that the derivative is undefined at those sharp points, but everywhere in between, the slope there is negative 2. And in the next segment, I have something similar going on. I can see that I have another line segment. I have sharp points on the end where the derivative is undefined. The slope is rise over run, so again my rise there is 4, my run is 2, but this time it's in the positive direction. So my derivative there is at 2. But notice what happens between 5 and 8. My function here is constant, so that means that the slope is 0. So my derivative is actually equal to 0 between 5 and 8. And then between 8 and 10, notice that I have a line segment that's decreasing again, so the slope is negative. It looks like my rise over my run is 1, but in the negative direction. So that is the graph of the acceleration or the derivative of the velocity function.